Okay, happy second quarter. We're taking a look at how waves are transmitted through various materials. It says we're writing what's in blue today, but obviously your notes are your own, so you can kind of take notes as you feel they are appropriate to be taken. So that is up to you. So we're just going to do a quick review thing here. You probably don't need to write these things down. What is a wave? These are vocab words from start of the unit. So you should know it's any disturbance that transmits energy through matter or empty space. They transfer energy by repeated vibrations. What they move through is a medium, and there are electromagnetic and mechanical waves. The electromagnetic ones are the ones that don't need a medium or can travel through space, rather. The mechanical waves need some form of matter to travel through, solid, liquid, or gas. So you can look at that today. Electromagnetic waves, as I just mentioned, they can transfer energy without going through a medium, can travel through all of the states of matter, and they can travel through places without matter, aka space. So types of electromagnetic waves, visible light. So the fact that you can actually see this coming off your computer screen, that you can see your computer as well, that is visible light. X-rays, that is the thing that they use at the doctor's office if you have a broken arm or something, they want to take a look inside you. That is a form of electromagnetic wave. Radio waves, those are in fact the things that transmit television and radio signals to you. Microwaves, you have a microwave in your kitchen and it does run on these kinds of microwaves. Infrared rays, those are the ones that actually cause a sunburn. They're why you wear sunglasses when you go outside. So they come directly from the sun. Gamma rays also come from the sun. They are a nuclear type of ray. And when you consider when there's a nuclear blast, that kind of thing, gamma rays are actually one of the types of rays that come out of there. Mechanical waves, you are aware they transfer energy by vibrating particles in a medium. All waves vibrate. It's just as a matter of if they have particles in a medium or not. They can travel through all states of matter, but they can't travel through space. Mechanical waves examples: ocean, sound, seismic waves, so earthquake waves. Ocean waves or lake waves, if you get on the Lake Michigan, same kind of concept. You've seen those moving. Sound waves are exactly what they sound like. The fact that you can hear me right now, that's sound waves. Okay, so the types of matter, hopefully you know, are solid, liquid, and gas. Waves travel differently depending on the type of matter they are traveling through. So we're going to take a look at that. Traveling through a gas, so the molecules in a gas are spaced out. They're not packed close together. That's actually one of the reasons that you can wave your hand around in the air. Just put your hands up, wave them like you just don't care. That's because we are surrounded by gas and the molecules are spread out. So the waves travel slowest through a gas. Gas equals travel slowest. It's because they're so spread out, makes it harder for them to actually move quickly. In a liquid, the molecules are sitting more next to each other. They're packed tighter than a gas. They're not the tightest, but they're packed tighter than gas. Waves travel at a medium speed through a liquid. Same kind of thing. If we were underwater and we put our hands up and waved them like we just don't care, harder to do it. Not impossible, but definitely harder because liquids are more closely packed together than gases. So you want to make sure you have those notes filled in. And then traveling through a solid, molecules in a solid are tightly lined up. They're packed tighter than liquid. As a result, waves travel fastest through a solid. That is why you cannot wave your hands through a solid. So if you were to try to do that, you would find that you get hurt. If anybody's ever punched a wall on purpose or on accident, definitely you find that you get hurt when you do that. So that is because that is a solid. Okay, a link to this site is actually being shared in the side margin for you, so you can take a look at this and see how waves in different mediums interact with each other. Oops, I feel like I skipped one. Yeah. In real life, the energy from the sun travels to Earth in waves. The light waves are electromagnetic. They travel as a transverse wave, so that one that goes perpendicular to the motion of the wave. They can travel through space, and they can travel throughout the Earth. So once they actually hit Earth's atmosphere, they're in a gas. They're going through a medium. Small amount of light waves from the sun get to Earth because the sun's energy radiates in every direction, not just towards the Earth. So the same kind of concept as if you were to take a light bulb that doesn't have a lampshade on it, just like a light bulb sitting up in the middle of a room, and turn it on, you'd see that it lights up all around the room, not just in the direction where you're standing. The sun works the same kind of way. It's the same kind of concept. And so with that light bulb, only a small amount of light actually hits you. The rest of the light kind of goes all over the room. Same thing with the sun. It's like the light bulb in the middle of the room, except the middle of the room is the middle of our solar system. Okay, earthquakes are seismic waves. They travel through the Earth's crust. So they are a type of mechanical wave, and they travel through solid Earth. They travel as a transverse wave as well. And the energy in seismic waves can be very destructive to anything on the ground. Very small picture that we have there, but if you look kind of closely, you can see that it is just giving you an example of how the two types of seismic waves move, S and P waves, direction that they might move, and then it shows you just a cutaway of the Earth. So we'll get more detail on that as we go forward. And that is what we're discussing with waves for today. Hopefully you got those notes. If you have any questions on it, definitely feel free to ask. Like I said, you can take your notes on paper. You can take them on a Google Doc. There was one that was shared out with these notes. So have a great day. Thanks.